Today I am going to walk you through how a glycol feed system works. We will look at its purpose, the key components, and the step-by-step operating sequence. This explanation is perfect for beginners and anyone who wants a clear understanding of how glycol systems stay stable and protected. A glycol feed system automatically delivers glycol to a larger closed loop whenever the pressure drops. It prevents freezing and keeps the system operating at stable conditions. You can think of it as a helper that always watches the pressure. When the main loop loses fluid, even a small amount, the glycol feed system detects that drop and adds more glycol. It only runs when needed and shuts itself off as soon as the pressure returns to normal. The glycol tank stores the concentrated glycol solution. The gear pump is the force that draws glycol from the tank and pushes it into the system. The pressure switch monitors system pressure and decides when the pump should start or stop. The control panel allows the operator to choose between off, hand, or auto. Hand means the pump runs continuously. Auto means the pressure switch controls everything. The low-level switch is a float that activates a warning light if the tank level gets too low. This protects the pump from running dry. The check valve stops any backward flow from the main system. The Y strainer is a small filter that catches debris before it enters the pump. Now let us break down the operation when the system is in auto mode. The pressure switch is always watching the pressure in the main loop. This usually happens when the system loses a small amount of fluid or during maintenance. As glycol enters, the pressure begins to rise. When pressure reaches the high limit setting, the switch turns the pump off. The pump pulls glycol from the tank and sends it into the main loop. The check valve closes and prevents any backflow into the tank. The system waits. If pressure drops again, the cycle repeats automatically. Even though the operating sequence is simple, this equipment is essential for protecting closed loop systems and keeping them stable.